Hello students, most welcome to Dr. Acharya Academy. Today I am going to discuss on the periodic trends in chemical properties in respect of valence or oxidation states. This topic has been taken from the NCERT Chemistry Class 11 books. This is the part 1, unit number 3. Today's class number is 060. Today's learning point is the periodicity of the valence or oxidation state, which is shown by element. First, we'll see the periodic table. In this periodic table, as you know, in the left side, this part, group 1 and group 2 is the representative elements, and extreme right side of from group number 13 to group number 18, all are the representative elements. The valence is the most characteristic property of the elements and can be understood in terms of their electronic configuration. Electronic configurations of different elements I already discussed in the previous class. You can go through those classes to understand clearly about the electronic configurations. The valence of representative elements, just now you have seen the representative elements, different groups. So the valence of these representative elements is usually equal to the number of electrons in the outermost orbitals and or equal to 8 minus the number of outermost electrons. So in the first case, equal to the valence is equal to the number of electrons in the outermost orbitals. In this example, you can see the lithium electronic configuration of 1s2 2s1. So outermost orbital is this 2s1. So in 2s1, the number of electrons is 1, and therefore the valence of lithium is 1. Now we'll discuss about this part, that equal to 8 minus the number of outermost electrons. So if you consider the nitrogen atom, so nitrogen's electron configuration is 1s2, 2s2, 2p3. So outermost orbitals, outermost shell, what is this? 2s2 and 2p3. So in this case, the number of electrons in the outer shell, what is this? 5. And so the valence of nitrogen is 3. How? 8 minus 5. Here you see 8 minus the number of outermost electrons. Outermost electrons is 5. 2s2, 2p3. For 2s orbitals is 2 and 2p orbitals it has 3. So total 2 plus 3, 5. So this is the 5. 8 minus 5 is equal to 3, which is the valence of nitrogen. The term oxidation state is frequently used for valence. Consider the two oxygen containing compounds. That means oxygen present in two different compounds. One is OF2 and another is Na2O. So with this example, we want to show that how electronegativity affect the valency or oxidation state. The order of electronegativity of these three elements, that means oxygen, fluorine and sodium. So it is in the order in respect of electronegativity. Fluorine is the most electronegative element and comparatively less electronegative oxygen, and electronegativity is lowest for the sodium in these two compounds. So each of the atoms of fluorine with the outer electronic configuration. What is this? Outer electronic means outer shell is the second one, 2. So 2s2, 2p5. This is the outer electronic configuration for fluorine. So here the fluorine atoms share one electron with oxygen in the OF2 molecule. So OF2 has 2 fluorine atoms. So one electron from each fluorine atom, it will be shared with the oxygen. Being the highest electronegative element, fluorine is given the oxidation state -1. Since there are 2 fluorine atoms in the OF2 molecule, oxygen with outer electronic configuration, what is this? 2s2, 2p4. So obviously, what is its valence? 8 minus 2 minus 4. That means 2. 2 valence is with the oxygen. And this oxygen is comparatively less electronegative than chlorine. So this oxidation state will be denoted by the plus symbol, that means +2. Now we'll consider about the compound Na2O. Here we know that O is more electronegative element than sodium. So whatever the oxidation state is with oxygen, its symbol will be minus. So oxygen, in this case, that means in this compound Na2, its oxidation state is -2. For sodium with electronic configuration, what is this? 3s1. So outer shell electron configuration is 3s1. That means 1, as per our previous discussion, it will be its valence or oxidation state. And this sodium is comparatively less electronegative than oxygen, so its symbol will be the plus. So its oxidation state will be +1. So valence we represent here as the oxidation state with proper symbol in respect of electronegativity of different elements in a particular compound. Thus, the oxidation state of an element in a particular compound can be defined as the charge acquired by its atom on the basis of electronegative consideration from other atoms in the molecules. In the next chapter, when we will discuss about the chemical bonds, we will know more details about this oxidation state. Here, only we want to show the periodic trends of the oxidation state in respect of electronegativity in a periodic table. Now I will discuss on one problem. Using the periodic table, predict the formulas of compounds which might be formed by silicon and bromine, and another compound will be formed by aluminum and sulfur. So what is the solution? First, these elements we have to arrange as per the groups. So silicon is group 14 elements with a valence of 4. And bromine, this part bromine belongs to halogen family We know the halogens family, every element has valence of 1. So bromine also has valence of 1. And hence what is the formula? That means silicon, 1 silicon atom, so Si, and 4 bromine will attach with it. So Br, and number of atoms, this 4 as per the valence. So it will be the subscript of Br. So it is the formula of the compound formed by the silicon and bromine, and it is SiBr4. Similarly, you consider about the aluminium. Aluminium belongs to group 13. So what is valence? Valence is 3. Now sulfur. This is a sulfur. So sulfur belongs to group 16. And we know the valence or the elements belongs to the group 16 is 2. So for the sulfur also its valence is 2. So what will be the formula? What is the compound in this formula? That means the aluminium valence is 3. In this case, 3 number sulfur atom will attach with the aluminium. And what is the valence of sulfur? Sulfur is 2. That means 2 number aluminium atom will attach to the 3 number of sulfur. So its chemical formula is Al2S3. So in this table, you can see some periodic trends in respect of the valence of elements. That means if you consider the group number 1, all hydrides and oxides, group number 2, hydrides and oxides, and for other groups also, you know, we are talking about the representative elements. Representative elements belongs to the group 1, 2, 13, 14, 15, 16, 17. I hope that you understand now what is the valence, what is the oxidation state, and how it relates with the electronegativity to form different compounds. I have also podcast in the same name, Dr. Acharya Academy, for the honors and degree chemistry level education. You can go through this to gain more knowledge about this. Thank you so much for watching this class.